We went from the generic idea of a list, which just means an ordered sequence of elements, into the slightly more specific idea of a linked list being the way that it's typically implemented, that the sequence is managed by each node having one link to the next node. Now, this is a linked list, but to be yet a little more specific, this is called a singly linked list, where we have a single link forward in each node. But we can also have a doubly linked list. The difference here would be one more piece of information for each node. Instead of each node having a reference just to the next node, we add one more piece of data that it also has a reference to the previous node as well. Now, to represent this visually can look a little intimidating because I'm showing the idea that these objects can be located anywhere that's convenient in memory. They don't have to be next to each other. But each object only has two extra pieces of data, a reference to the next object and a reference to the previous object. So this is a doubly linked list. It allows us to go forward and backward, to traverse the list in any direction. Now, that might not immediately seem that useful, but it makes several operations a little easier. For example, we talked about the idea of removing items from the middle of the list. Now, with a doubly linked list, I always have a reference to both the previous node and the next node. It's super simple to make any changes that I need to do, so both removing and inserting is simpler with doubly linked lists. And as we'll see in a moment, when linked lists are implemented in languages, they are typically implemented as doubly linked lists. Now, one question might be, what should we do with the first and last node of the list? Now, I've already talked about the idea that the final node, in this case object 5, its next link might be set to either a null reference, saying we're not going anywhere after this, or it might point to a terminator or sentinel node to explicitly indicate we've hit the end of the list. Now, with a doubly linked list, this is also what you would do for the previous link on the first element. So object 1 previous link also points to the sentinel or terminator. However, there is another option for this, is that rather than these starting and finishing nodes pointing to a terminator, instead you point the final node's next reference back to the first node and the first node's previous reference to the final node. Now, this would be considered a circular linked list, or in this case, a circular doubly linked list. It's not typical, but it can be useful for certain problems, that if we get to the end of the list and say next, we just start again at the beginning. So we have singly linked lists, we have doubly linked lists, we have circular linked lists. Let's see what kind of support exists for these across common languages.